All right, today we're going to talk about absolute value equations eventually. But before we can do that, we need to discuss solving some disjunctions and conjunctions. All right, so I don't know if you saw this in Algebra 1. I don't think you did. You may have. But I just want to go over a few of these inequalities and when I put two of them together. All right, so in this case, I'm connecting them with the word or. All right, so with the word or, we call this a disjunction. And now look at the graph. How does the graph look when you graph a disjunction? It has two separate pieces, and where are they going? They're going away from each other. So the way to make this true is it only needs to satisfy this first piece or this second piece. It does not need to satisfy both. And in fact, in this case, could you have a number that satisfies both? No, there's no number that would make both of these true. That's why it's or. So this one or that one. Okay, so it just needs to make one or the other true. That's called a disjunction. The other one we're going to talk about today is a conjunction. All right, that's connected by the word and. And you can see in this case, instead of going away from each other, they're doing what? Bless you. They're coming together. All right, they're going towards each other. So in this case, in order for a number to work, it needs to make both of these true. This piece and this piece. So it must make both true. Otherwise, it's not a solution. Okay? A way to help you remember that, if you think about prefixes that you learn in English, dis means apart or separate, and con for conjunction means together or with. And you guys that know Spanish, right, you have the word con. What does con mean? It means with, so you can think of that too. All right? Okay, great. So let's look at a few examples. In number one, and the first thing I do with these problems is I ask myself, is it a disjunction or a conjunction? And how do I know? Where am I looking? At the word. At the word. The only word here is or. So I'm going to write disjunction. It's not required. It just helps me make sure that my graph matches up with what I expect it to be. Okay? Because at the end, I am going to graph it. Now, we're going to have two separate pieces that I need to solve for x. So let's isolate x. How would I do it here? Minus 3 from both sides. So we have x is less than or equal to -1. That's the first piece. All right, connected by the word or. What about on the right-hand side, the right piece? Divide by 3. So I'm going to have x is greater than 3. All right, now again, these problems are not complete unless you show the graph as well. All right, so I've included this slide a number line that we can use to graph. So I'm going to find 0. Oh, there it is. All right. What kind of circle am I putting at -1? What does it say here? What does that line mean? It means or equal to. So that means it's going to be closed at -1. Which way am I going to draw my arrow for less than -1? To the left. All right. It goes on forever. So I show that arrow. Now the other number is at 3. What type of circle at 3? Open. It does not have the or equal to. So I go 1, 2, 3 in an open circle. All right. And which way do I go for greater than that? To the right. All right. Now everybody that I've ever taught this to can do this with enough practice. But I want you guys, again, I'm not trying to teach you to be like robots where I just tell you to do something and you do it. I want you to be able to think and tell me what it means. So if I look at this right here, could you give me a solution to this disjunction? A number that would work. So that's what I want you to know, right? Does it need to make both of them work? And in fact, can you find a number that makes both of them true? No. All right, so what would be a solution? 4, let's see. 4. Is 4 plus 3, that's 7. Is 7 less than or equal to 2? No, it doesn't make that piece true, but it still has another chance. What's 4 times 3? 4 times, sorry, I said 7 first, but 4 times 3, sorry. 12. Is 12 greater than 9? Yes, and if you notice, 4 is in my shaded area right there. Okay? What's a number that will not work? 1. 1 plus 3 is 4. 4 is not less than or equal to 2. 1 times 3 is 3, and 3 is not greater than 9. And if you notice, where is the number 1? It's not shaded. Okay, so do you guys see how you can use the graph to give you answers? Okay? I want you to be able to do that. I think a lot of students don't realize that that's what this shows. It shows you what are your possible answers for x. Okay? Any questions on a disjunction? All right, let's go to a conjunction because I'm using the word and. All right, so again, on the left side, how am I going to isolate that x? Divide by -2. You should have alarm bells going off. Why are alarm bells going off in your head? Because we're dividing by a negative, which means I need to do what with this less than symbol? Make it greater than. All right, what is 8 divided by -2? -4, very nice. And what about on the right side? What do I do to isolate? Add 3 to both sides. So I get x is less than or equal to 5. All right, again, this is not complete until you graph it. So I got 0 here. What kind of point at -4? An open. 1, 2, 3, 4, open. Which way am I going? Because I want numbers greater than. To the right, but do I go on forever? No, I have to stop where? 5. 1, 2, 3, 4, 5. And that's a closed circle. All right, so if you notice, they're coming together. Any questions on a conjunction? What's a possible answer, Marcelo? 1. How do you know that that's definitely going to work? Because it's inside the circle? Inside the shaded area, right? Where our solution set is. Okay, as long as you pick a number in there, you're good. Yes, Kayla? Because this does not have or equal to. So if I plugged in -4, it would not work. Because -4 times -2 is 8. Is 8 less than 8? No, that's false. Okay, so that's why it's open. This one gets to be closed because it has the or equal to. So if I plugged in 5, what's 5 minus 3? 2. Is 2 less than or equal to 2? Yes, it works. Okay. Any questions on this? Everybody good? All right, let's stand up and you guys can try them on your own. Go!